Hey there. The Geosciences Department is in that geology building. It's here on the Old Main Quad with Old Main. And let's give you a tour of the facilities. Hey, before we go inside, I want to show you the Centennial Rock Garden. It lines the whole front of the building, and we use it for teaching purposes and outreach. And we've got rocks from the region organized by geologic age, from old to young, going from west to east. The Geosciences Department occupies about 3/4 of the building, and I want to take you on a tour of a handful of research facilities, but also first we're going to go check out our Geology Museum. Welcome to the Geology Museum. It's not very big, but we've got a couple of cool things. One of the highlights is in our dinosaur corner, and this is Percy the Utah Raptor. Percy here is a sculpture made by an undergraduate student at USU, and it's perhaps the most accurate and up-to-date depiction of a raptor with all of his feathers and colors. Utah Raptor was actually the largest of the raptors, and so this sculpture is just 1/3 scale. And his full size is here on the wall. Just two more things I want to show you. First of all, we've got some nice Green River fossils in the case and on the wall. The Green River Formation, of course, is very nearby, and so these famous preserved Eocene fossils are really abundant and close by for our students and visitors. The other thing I want to show you is this huge Asian elephant ear that is fossilized and that we excavated in New Jersey and brought to the museum here. Okay, actually this is an Inoceremus clam from the Cretaceous, and somebody else has told me that it is the largest clam known in geological history, and it is very large. Hey, let's see if we can find a professor in their office. This office is way cleaner than usual, but it's quite spacious. You can see the shelves over there. Oh, and look, hiding behind the computer, there's Dr. Alexis Holt.
Hello, let's go check out some of our labs. We are in the basement lab suite of the Mineral Microscopy and Separation Facility. This lab houses a recently refurbished jaw crusher and disc mill that are a critical part of the mineral separation process. So this is where we break down rocks into minerals such as apatite and zircon, which are used for low temperature thermochronology and geochronology. Importantly, we have recently installed a dust suppression system and backdraft ventilation system that is used to collect fine particulates that are generated during sample processing. So this is where sample processing in the Department of Geosciences starts. Located next to the jaw crusher and disc mill is our recently installed Wolfley table. This is a water table or a glorified sluice box that is used to separate out accessory phases such as apatite and zircon by density. Okay, and the final component of our basement lab suite is our recently installed Franz, which is a magnetic separator that has a magnet that is used to separate out phases by their magnetic properties. Okay, these are the upstairs labs in the Mineral Microscopy and Separation Laboratory Suite. The outer lab has a fume hood, and it also has a space that is designated for making mounts for the scanning electron microscope. We have an inner lab that is our picking lab. This lab houses 2 Leica stereoscopes. These are scopes that are used for selecting and loading accessory phases for uranium, thorium, helium analyses, uranium, lead analyses. This stereoscope is interfaced with a Leica camera, and that connects to a computer with Leica application suite software that allows us to image and measure aliquots in real time. This is one of our research microscopy labs. This lab houses our Raman spectrometer and also a suite of petrographic microscopes. We have a macroscope, which is capable of producing near full thin section photomicrographs. And we have two standard petrographic scopes. These are Leica DM2700s. They are interfaced with cameras that connect to Leica software. This is our newest scope. This is a fluorescence microscope. It has both reflected light and fluorescence light capabilities. Our Raman is equipped with 3 lasers. We have a 532, a 633, and a 785 wavelength laser suite. And so this allows us to analyze a wide spectrum of samples. We can analyze solids or samples that are in thin section or in sample chips, and we also have a cuvette that allows us to analyze fluids. This system is equipped with a fluid inclusion analysis setup, and so we have a Linkum stage. We can do heating and freezing measurements on samples to back out the chemistry and temperature of fluids in samples.
Okay, here's what an office really looks like that's all busy and cluttered. And here's Dennis Newell.
Hello, how about we go check out a slightly cleaner space? Let's go downstairs to the Isotope Lab. So welcome to the Department of Geosciences Geochemistry and Isotope Labs. This is the general geochem space. We have 2 hoods that we use in here, one for sort of general use and one where we do some dissolutions, acid dissolutions, such as with hydrofluoric acid. And if we walk into this room here, this is the Stable Isotope Lab. And over here is our core instrument. We have a thermoscientific Delta 5 Advantage isotope ratio mass spectrometer. And we also have several peripheries that go with that. We have a Costech elemental analyzer. We have a gas bench. You can kind of see down over on this side of here with an auto sampler. And then we also have a thermo TCEA. And what this allows us to analyze, we start with the gas bench. We have methods established for doing carbonate, carbon and oxygen. We do water, oxygen on this. We can also do various gases, including the CO2. On the elemental analyzer here, we do primarily organic matter. We do carbon and nitrogen stable isotopes on that. This instrument can also be converted to do sulfur isotopes, but we're not doing that at this time. And in the TCEA, we do hydrogen isotopes in water using this instrument. We do oxygen in a variety of things, including cellulose. And we also can do hydrous minerals such as muscovite for hydrogen isotopes. Okay, so that's the stable isotope space. When we walk over here and go into this room, a little bit noisier in here because of the vacuum pump. But this is our quadrupole ICP-MS, and it has a laser ablation stage that is taken apart a little bit right now because we're replacing a few parts on that. I will note that this instrument here has been here a while and it's still collecting good data, but it is probably nearing the realistic end of its service life. In here we have a furnace that we use for doing for melting rocks for a variety of applications. Okay, so that's the isotope space. And if we walk into this room, this is our much quieter X-ray analysis laboratory. And in here we have an XRF, pan-analytical XRF, and then also a pan-analytical XRD. In addition to these larger instruments, we do have a handheld XRF that we use for qualitative analysis of things, but we've also developed some methods for doing pretty good quantitative work with the handheld instrument.
The last research lab I want to show you is actually off campus at the research campus. And so we're going to leave out of the back door of the building.
Okay, so here we are in the outer Luminescence Lab. This is the part of the lab that's in the light. Most of the activities happen behind this rotating door. And with luminescence dating, we're dating the last time that sand was exposed to light. So the first trick is to collect your sample without removing its luminescence signal. To do that, we take metal pipes and we pound them into sediment exposures to extract the sediment, and then we date what's on the inside of the pipe. The technique can date things that range from 100 years old to 200,000 years old, and in cases 500,000 and up to a million years old. The lab here hosts a couple lab managers and some student technicians. We also have an annual short course where students from across the globe come here to learn this technique, because there's only a few labs in North America and across the world that do luminescence dating. So once the samples are collected, we bring them into the dark, and the inner part that you cannot see because no light sources are allowed in there, we're just processing samples similar to a sedimentology lab to extract quartz and feldspar sand. Further back in the darkroom is another innermost darkroom where the instruments are that measure the luminescence. Here at the Luminescence Lab, we use instruments that read the luminescence that come off the samples. They're called OSL readers, and they're built in Denmark, specifically out of Riso National Labs. Okay, thank you for visiting. I'm gonna go do some work.